Hi, everybody. Here are the homework answers for homework U7L4. Why does it say 4? U7L4. So we are now working into factoring. The first part of the questions, question 1, was just wanted to get us into the groove of when we have conjugate pairs, the plus and minus in between the same numbers. You're seeing that the middle term disappears, and they want you to get really quick about it. Why? So we can visualize it when we have a binomial that is two perfect squares. For example, we have 16 and we have 1. We can, in question E, 1E, we would know quickly when we get to question 2 that those are perfect squares. 16 is a perfect square, 1's a perfect square. I would love you all to please memorize the first 15 perfect squares. What are the first 15 perfect squares? We have 1 times 1 is 1, 2 times 2, 4, 9, 16, that should be a 16. We have 25, 36, 49. That should be a 4. Sorry, guys. Then we have 64, 81, 100. Then we have 121. We have 144, 169, 196, and we have 225. Okay. I would really love you guys to memorize all those, because when we get to having to quickly do conjugate pair factoring, it's just really, really great to have all that knowledge quickly and easily. So that's that. So now let's talk about questions 2. It sounds like everyone was pretty good with it when they emailed me. A few things I want to point out. Things such as question K. You have to keep the 9 first. Do not flip-flop it around because you really want to have the variable first. You have to have the 9 first. Why? Because that negative and positive is with the t. It's not with the 81. So when I'm doing this and I'm thinking about the fact of I have the factors, when I'm trying to factor, I have 81. 81, I'm trying to think 9 times 9, and here I'm thinking 2t times 2t. Okay, but that negative is with, one's with the t, 2t, and one's with the positive 2t. So you have to have 9 minus 2t times 9 plus 2t. Does it matter if I have the plus or the minus first or second? No, it does not. Commutative property, it does not matter. Okay. The other one I want to mention to you is question L. We have x to the 4th. Again, just like I want you guys to know the perfect squares, I'd like for you guys to know the perfect squares of variables. And what are they? A even exponent is always going to be a perfect square. So for example, we have x times x, that equals x squared. We have x to the 2nd times x to the 2nd, that's x to the 4th. We have x to the 3rd times x to the 3rd, and we get x to the 6th. Okay, and one more, x to the 4th times x to the 4th will give us x to the 8th. So you can see that if the exponent is even, it is going to be a perfect square. So in that case, when we're doing a problem like question L, it's going to be x squared first. Right? We're usually doing x and x. And then what are we left over with? We're left with 6 and 6, and one's plus and one's minus, or vice versa. It doesn't matter. So let's talk about page 2, because a lot of people were saying, oh, I didn't know how to do it. Okay, I want you all to know that you do know how to do it. You just need to feel comfortable that you the knowledge we learned today, and then taking into account some of your knowledge about the world in general. Let's look at it here. A square is changed into a new rectangle by increasing its width by 2 inches and decreasing its length by 2 inches. Make sure to draw a picture to help you solve the problem. So if the original square had side lengths of 8 inches, find the area and the new area. So we have 8 and 8, so we're left with 8 times 8, which is 64 inches squared, right? If I take the width is 2 less, right? 2 less. That would be 8 minus 2, which of course is 6. And then the length is 2 more. That's going to be 8 plus 2, which is going to be 10. I'm going to do 6 times 10, which is 60 inches squared. So I can see the difference is 4. 4. Let's try the next one. What if I had 20 by 20? Well, 20 times 20 is 400. And if I, again, subtract 2 from the width, I add 2 to the length, I get 18 times 22. I don't know that math off the top of my head, so let me just do that real quick. And we're dealing with 18 times 22. Enter. And we get 398, which, okay, and that's inches squared, of course, and that's inches squared. So the difference, again, is 4 inches squared, okay? So they want us to take this whole concept and see whether we can figure out what the, show that the area will always be 4 inches more. So let's do this. So if we're having inches, x times x, we're left with x squared, right? And then we all know that when we multiply a conjugate pair, we're left with x squared minus 4. And there's your answer right there. Okay, don't worry about question 4. I really am not going to worry about it too much. And then question 5 was just like what he was doing, where we want to try and see that we have a, it pretty much was the same thing we just did. Okay, so hopefully that was good. Come to the office hours if you're able to. I'm going to try and do them every day from 10 to 11. Have a good day, everybody.